Dear students, after studying this module, you shall be able to understand the synthesis and reactions of bridge rings. A bridge ring compound is an organic compound that has two or more rings possessing a bridge. A bridge is a connection between the two atoms with a single atom or a chain of atoms or even a valence bond. The two connecting atoms are called bridge head atoms. The bridged ring compounds are either fully carboxylic or all carbon atoms, or even heterocyclic having one or more non-carbon atoms in nature. These types of compounds are frequently found in natural products. The bridged compounds follow a Bread's rule. The Bread rule says the bridged bicyclic compound cannot have double bond at a bridged head position unless one of the ring contains at least 8 carbon atoms. A ring with less than 8 carbon atoms unstable and violates the Bread rule, whereas any ring with the double bond at a bridge head position with the 8 carbon atoms are stable, Bread's rule. Nomenclature of the bridged compounds. The bridged ring nomenclature uses prefix, suffix and a bracket term. The prefix is for the number of bridged rings like bicycle, tricycle, etc. and also those rings include any heteroatoms like oxa, thia, eza, etc. The suffix is for the total number of atoms in the bridged ring compound. Inside the bracket, the number of carbon atoms in each of the bridges connecting the two tertiary carbon atoms is indicated in the descending order. For example, bicyclo 1,1,0-butane. This indicates in this suffix we have two ring systems bicyclo. Each of the ring contains one carbon atom and the two carbon atoms at the bridged head positions connected to each other without any interlinking carbon atom, and henceforth the bracket has 1,1,0. The suffix is the total number of the carbon atoms, which is 4 carbon atoms, indicating butane. Let's look at another example, which is bicyclo for the two ring systems, 3 for the ring system on the right hand side, which is the 1, 2, 3 carbon atoms, 2 on the left hand side, which is 2 carbon atoms, 1 carbon atom in between two bridge head positions, so 3, 2, 1, and octane for the total number of 8 carbon atoms of the complete structure. Another example, bicyclo 5,2,0-nonane. The complete structure has 9 carbon atoms linked at the bridge head position with no carbon atoms interlinking the two, 5 on one side and 2 on the other side, which have been indicated very clearly in the brackets. The system is numbered commencing with one of the bridge head positions, numbering proceeding by the longest possible path to the second bridge head position. The numbering is then continued from this atom by the longer unnumbered path back to the first bridge head and is completed by the shortest path from the atom next to the first bridge head. Let's look at this through an example, bicyclo 3,2,1 octane. We move from 1, 2, 3, 4 and 5 position through the longer pathway, reaching to the second bridgehead position starting from the first bridgehead, moving back to the first bridgehead through the shorter path, which is 6, 7, and finally from one bridgehead to the other bridgehead again through the shortest path. The numbers are very evidently clear from the given structure. Synthesis of the bridge rings. Diels-Alder reaction. The intramolecular Diels-Alder reaction are widely used for the construction of bridged ring compounds. The use of two substituted butadiene giving a series of bridged head alkenes and bridged head enol lactones. The reaction proceeds by the simple heating at high temperature or sometimes catalyzed by the Lewis acid. It leads to the formation of bicyclo-331 non-5-ene 2-one. The reaction is carried out by a simple heating at a high temperature leading to the intramolecular cyclizations. The intermolecular Diels-Alder reactions are also being used for the construction of the bridged ring compounds. The conjugated diene having S-cis conformation like 1,3-cyclopentadiene is highly reactive and a suitable substrate in a Diels-Alder reaction. The cyclic diene gives a bridged bicyclic compound through the Diels-Alder reaction. We can see 1,3-cyclopentadiene in this S-cis conformation reacts with propene ester leading to the formation of a bridged bicyclic compound. Both these rings share one carbon atom and leading to the formation of the two isomers, one in the cis and other in the trans position. Similarly, 1,3-cyclopentadiene is also seen to react with propene nitrile, forming the two isomeric bridged bicyclic compounds. The formed bridged bicyclic compounds give major and minor products based upon the stability. There are two possible configurations for the bridged bicyclic compounds based on the position of the substituents. If the substituent R points towards the double bond, an endo configuration is possible, and if substituent R points away from the double bond, the exo configuration is expected as depicted here in the given figure, the endo and the exo. Endo points towards the double bond and the exo is away from the double bond. The formation of the endo product is normally a preferred product and is formed faster when the dienophile possesses a substituent with pi electrons. This is probably due to the less of the steric hindrance. The intermolecular Diels-Alder reaction of cyclopentadiene and cyclohexadiene with ethene also gives the bridged ring compounds. The figures and the conformations are seen herewith, wherein the cyclopentadiene reacts with ethene, forming a cyclic bridge structure in the chair form, and it has a one single carbon atom linked in between the two bridgehead positions. Cyclohexadiene also reacts with the ethene, leading to the formation of a bridgehead compounds with the two carbon atoms at the two bridgehead positions. Reductive coupling. The synthesis of bridge rings by reductive coupling had been carried by Corey et al. They had reported a titanium-based reagent for the intramolecular pinacolic coupling of ketones and aldehydes. This cyclizing reagent was formed by the reaction of cyclopentadienyl titanium trichloride and lithium aluminium hydride. This induced intramolecular reductive coupling of wide variety of substrate free radical method. The bridge rings have also been synthesized by closure of vinyl radical at the beta position of the enone system. They also showed the formation of strained bicyclo 3,2,1 octane using this method. The azo-bis isobutyl nitrile is responsible for the generation of free radical as shown here. The free radical generated is by the loss of nitrogen. The radical generated is then made to undergoes the intramolecular cyclization leading to the formation of a bridged compounds. Reactions of nonbornean. Nonbornean is a bridged bicyclic compound. This is also known by the IUPAC name as bicyclo 2,2,1 heptanes. It is a crystalline compound with the melting point of 88 degrees. The compound is a prototype of a class of strained bicyclic hydrocarbons. These molecules are considerably strained molecules having high ground state energy associated. Due to this, these molecules undergo ring opening reactions very readily. These are very useful synthetic intermediates. The ring opening of nonbornean derivatives can be achieved using scission of any of the 4 topographically different carbon-carbon bonds. As can be seen, nonbornean can be cleaved through various ways, and we have 4 different type of the products which can be formed by the cleavage at the different carbon atoms. The reaction of nonbornean through path 1 offers an easy access to cis-1,3 disubstituted cyclopentanes. For example, the carbon-carbon sigma bond in succinic ester derivative of nonbornean has been found to undergo cleavage when reacted with sodium and ammonia at -78 degrees temperature. This concept was used by Gassman and Creary to get the ring opening of nonbornean derivative to yield cis-1,3 disubstituted cyclopentene derivative. The reaction of nonbornean derivative through path 2 takes place through the photochemical alpha cleavage of the cyclic ketones. Thus, alpha cleavage of 1-methyl nonbornean 2-one gives unsaturated aldehyde through abstraction of syn C7 hydrogen by the intermediate carbonyl radical, as shown here in scheme, which indicates the photochemical reaction of the bridged ring. The reaction of nonbornean through path 3 leads to cyclohexene derivatives. This type of cleavage requires a keto functionality at 7 position. The C1-C7 bond in the 7-norbornenones derivative on exposure to a base could be cleaved via the Haller-Bohr reaction to give the cyclohexene carboxylic acids, as here depicted in scheme. The reaction of nonbornean derivatives through path 4 takes place with the metal carbene complex leading to the ring opening. This is also known as ring opening metathesis. The product subsequently coupled with the acyclic alkene using cross metathesis method to provide a novel way of cleaving olefinic bond in nonbornean derivatives. The reaction of symmetrical nonborneans in presence of a slight excess of terminal alkene gives only tetra-substituted cyclopentane using a transition metal complex, as depicted here in scheme. The synthesis is of the saturated cyclopentane derivatives from the bridged ring compounds through ring opening. Ring expansion reaction. The synthesis of large membered rings like 8 or 9 are always associated with problem. One reason is there is high degree of ring strain and transannular reactions. The bridged rings provide an easy way to expand the ring. The reaction was optimized by Ghosh et al. That the 1,4-bis mesylates, when heated with zinc powder and sodium iodide in HMPA, to afford the bridged 8-membered rings as shown here. Some other reactions of the bridged compounds. The bridge ring molecules are very conformationally constrained. If a halide is present at a bridge head carbon, the heating gives no reaction at all. The non-reactivity of the bridged head rings having halide at the bridge head position is depicted here. These type of compounds have reservation towards SN2 mechanism. The compounds having leaving groups at bridged head carbons do not react with ethoxide ion under SN2 conditions. This is also expected for the bridged head carbons since there is no possibility for the nucleophile to approach from the rear. To summarize, the bridged ring compounds has 2 or more rings possessing a bridge. A bridge is a connection between the two atoms with single atom or a chain of atoms or even a valence bond. The bridged ring compounds follow Brett rule. The nomenclature of the bridge compound has been already discussed with suitable examples. The bridge ring compounds are synthesized by Diels-Alder reaction, reductive coupling, free radical method, but not restricted only to them. The reactions of the bridge rings allow the formation of open chain compounds, cyclic compounds and ring expansion compounds.